Hello everyone, welcome back to Biophilia, your all-time study mate. Today we are going to continue with the third part of this chapter with morphology of leaves. If you like our videos and get some help to understand the concepts, then don't forget to like, share and subscribe to our amazing channel Biophilia. Moving ahead with the chapter about morphology in flowering plants, हमारा third concept है regarding the leaf. So the leaves are going to be the lateral and these are going to be generally flattened structures borne on the stem. So leaves तो हम सब ने देखे होंगे, leaves are nothing new to you, but still here to understand more about leaves, these are going to develop from the nodes. So nodes हमने previous video में पढ़ा था that what is a node, and even we understood what is the internode. So likewise you can go and check out the other parts of this video as well. Link will be provided down in the description box. You can surely go and revise those videos as well. So coming back to the leaves, leaves are going to develop from the nodes and these will also have a bud that is coming from the axil. So exile के बारे में भी हमने previous video में discuss किया था. So I hope now you know what exile means. So the leaves are going to originate from the shoot apical meristem and it is also going to get arranged in the acropetal order. What is acropetal order? Acropetal order is going to refer to as the young leaves or the young organs of the plant are going to be located at the top area. So ऊपर की side पे the young leaves are going to be found, whereas the older leaves are going to be found at the bottom region. So अगर top region पे young है, older पे bottom है, और these are the larger leaves at the bottom, that particular order is called as acropetal order. So acropetal order में the leaves are going to grow, and here you can see in the image as well. The larger leaves are going to be situated at the lower area, so these are older leaves, and the leaves which are going to be at the top, these are going to be the younger leaves. So that is the order of acropetal arrangement. So generally leaves जो होते हैं, these are going to be the vegetative organ which are going to be used or which are going to function in the process of photosynthesis. Vegetative है because these are not going to be a part of reproduction. So not part of reproductive or reproduction, that means these are going to be called as vegetative organs. Now let us discuss about the parts of the leaves. So leaves को देख के लगा होगा कि leaves को तभी और कौन से parts में divide करेंगे. But now as you are studying over here in detail about leaves, leaves are going to have three parts. So the first part is going to be the leaf base. So leaf base जो है, as the name it is having base, so it is going to be the basal part of the leaf which is going to get attached to the node of the stem. So node of the stem क्या होता है या internode क्या होता है, everything has been covered in the previous part of the video, and link will be provided down in the description box. You can surely go and check out those videos as well so that you can revise those. So node of the stem के उधर से जो leaf originate होगा, so that basal part is called as leaf base. So leaf base के पास there are cases that they can have two lateral small leaves like structure called as stipules. So stipules ho या ना हो, it is the case or depending on the plant. So it is may bear. So not all plants have stipules, some may have, some may not have. So plants which have those, you can go and see those stipules which are going to be found at the leaf base. So stipules can be present or may not be present. So here are some photographs where you can see how the stipules look like. So these are small little leaf-like structures. वो leaves नहीं होते, but they look like leaves, which are going to be found at the leaf base. So यहाँ पे कुछ modifications हो सकते हैं of leaf base. So here we are going to try to discuss about the modifications of leaf bases. So modifications क्या क्या हो सकते हैं? The first one can be that monocots like banana. So banana के case में, if you might have seen the plant yourself, then you can see that there is going to be a sheath, यानी वो जो stem होगा, वो stem के side से the leaf is going to grow, and the leaf is going to be connected to the stem in such a way that it is going to form the stem, right? If you must have seen banana plant, आपको ये बहुत जल्दी समझ आएगा. So the sheath is going to be nothing but the leaf base. So leaf base of the banana plant is actually going to cover the stem. So the leaf base can actually completely cover it, or it can partially cover the stem. So if you try or get a chance to visit a banana farm and you can see those particular plants, then it might be much more helpful to understand how this sheath is actually going to cover, and that sheath is nothing but going to be the leaf base modification. So leaf base एक sheath के जैसे भी form हो सकता है, और in the case of some leguminous plants, so leguminous plants में the leaf base can actually swell up, it can enlarge in size, and it can form the pulvinus. So pulvinus is the second modification. The formation of sheath is going to be the first one. So pulvinus जो एक ऐसा enlarged area आता है, so you can see here in the particular diagram. So that enlarged, that swelled up area of the leaf base is going to be called as pulvinus, found in some of the leguminous plants. So that was about the leaf base, where it is present and even its modifications. अब लीफ बेस के आगे थोड़ा जाओगे, there is going to be a slender stalk. That cylindrical slender stalk is going to be the region or the part of the leaf which is going to join the leaf base to the leaf blade. So leaf blade is nothing but the third part of the leaf. So जो leaf base होगा, so leaf base क्या करेगा? Leaf base is going to be the point wherein it is going to get attached to the stem. But stem से लेकर उसका जो पत्ते का जो हरियाली वाला region होता है, that area तक का जो stalk है, the stalk of the leaf is called as petiole. So it is going to hold the leaf blade above the stem so that it can provide sufficient light. So अगर ये petiole नहीं होता था, if you might have seen in lower classes or young children, so drawing classes में sometimes they draw the leaves which are going to directly grow from the stem. So directly growing from the stem, that means the petiole they have not shown. But generally, how do you make a leaf? You are going to show a leaf which is going to have a stalk, and that stalk के आगे जाके you are going to show the leaf. So that little line that you formed before drawing the leaf is nothing but called as petiole. So these small little things that you do without noticing also can help you to remember. So likewise you can try to remember what is petiole. Petiole is going to be the stalk of the leaf. So it is going to be long, it is going to be thin, flexible, so that whenever wind is blowing, जब बहुत तेज तूफान आता है, पत्ते generally जल्दी से झड़ नहीं जाते हैं. You just blow and the leaf is not going to fall off. Why? Because the petiole is going to be flexible. So when the wind is going to come, वो जो पत्ते ऐसे लहराते हैं, that makes you feel happy and that gives you wind below the tree. The cooling effect, that is going to be the fluttering because of the flexibility of the petiole. अगर directly वो leaf base के बाद अगर leaf blade आ जाता था, then it would not have been the case. The leaves could have fallen off the tree. But now because of the petiole, the flexibility, the leaves can stay and they can also show some movement with the wind. So that was about the second part of the leaf, that is petiole. The third is going to be the leaf blade, or also called as leaf lamina. So leaf lamina is the green expanded part of the leaf which is going to be supported by veins and even veinlets. So veins are the larger vessels, veinlets are the smaller branches of the veins. So the prominent one vein which is going to be present in the middle, is nothing but called as the made rib. Since it is present in the middle of the leaf lamella, usko bolenge mid rib. So if you can try to notice the mid rib over here, then the mid rib is going to be generally from the continuation of the petiole. So यहाँ पे petiole होगा, petiole के साथ साथ ही there is going to be in the center that is called as the mid rib. So the midrib is further going to divide into veins. So generally veins midrib से थोड़े छोटे होंगे, but these are going to be the veins. और veins में से जब छोटे छोटे further partitions होंगे, those further divisions are nothing but going to be called as veinlets. So all those veins and veinlets, all those are going to be having a connection together so that they can provide rigidity. यानी easily वो leaf को ऐसे कोई it is not going to be a very thin structure. These veins and veinlets are going to provide rigidity as well as strength. And also these veins are going to act as channel for transportation. So जो भी water, minerals या food substances है that the leaf is going to make up, all that is going to go in and out of the leaf through these veins and veinlets. So not only for support structure but also for the transportation, these veins and veinlets are going to be helpful. So here in this particular diagram, you can see the leaf blade. You can prominently visualize about the petiole, as well as you can notice the particular part that is called as leaf base, or leaf base के उधर you can see two leafy structures that are called as stipules. So this particular image is a zoomed one, so you can imagine all the little parts that can be seen over here. Now as we have seen about the leaf lamina या leaf blade के बारे में जब हमने पढ़ा, we saw that there are going to be various veins and veinlets. So veins और veinlets जब एक दूसरे को arrange करते हैं in various arrangement patterns, those are nothing but called as venations. So various types of arrangement of veins and veinlets are the study comprised called as venations, which can be seen in two variations like reticulate venation या parallel venation. Reticulate venation जो होता है, the veinlets are going to form a network. वो एक ऐसा mesh type work बनाएंगे, वो एक ऐसा बहुत जाली जैसा बनाएंगे, and that mesh work or that network is going to be found in the reticulate venation, which can be generally seen in the case of dicots. So generally, जैसे you considered that the taproot system is found in dicots, likewise reticulate venation is believed to be generally seen in the case of dicot plants. So examples you can remember that reticulate venation can be seen in the case of peepal tree, in the case of hibiscus, also called as China rose, and the loofah. So आपको बहुत बार बचपन में ऐसे मतलब you might have done this activity that try to collect a leaf of peepal tree, और peepal tree के पत्ते को आपने उठा के the dried one you have tried to kept it in a very big book. So big book के अंदर आप उसे बहुत सालों तक रखते हो, and once it tries to get dried up, उसका जो green part होगा वो सब का सब चला जाएगा, and whatever is finally left out is going to be the net, the transparent net, which is going to be very fascinating, a very delicate piece that you can have of your own. So बहुत सी बार ऐसे बचपन में with your grandparents you can always go and collect this particular leaves and you try to keep it in old books. So this particular fashion things that you keep are nothing but going to be the example of reticulate venation. So वो अगर आपके पास होगा, so you can try to go and observe that net function, because वहाँ पे green part नहीं होगा, and you can very clearly see how the veins and veinlets are going to get arranged in a network, also called as reticulate venation. The second type that you can find is called as parallel venation. Parallel venation में जो veins होंगे, these are going to run in parallel to each other, and even to the lamella. So जो leaf blade होगा, the leaf lamella होगा, उसके parallel में these veins are going to grow, and majorly these are being seen in the case of monocots. So जो there are pujas in Indian traditions. So mainly in puja conditions या पुराने ज़माने में you can also see that people used to eat on banana leaves. So even if you get a chance to eat on a banana leaf, you can observe the leaf, wherein the leaf is going to have this type of parallel veins that go all around. So this is nothing but the parallel venation found in monocots like banana, wheat as well as rice plants. So ये जो ऐसे छोटे छोटे activities होते हैं that you do, but you don't do it with the purpose to understand how the nature works. So now as you know about it, you can always go and give some time to understand what you had done previously. आपने ये ऐसे लीव्स कलेक्ट करके ओल्ड बुक्स में तो ज़रूर रखे होंगे. You even might have got one particular type of this network which is reticulate venation. उस टाइम पे शायद नहीं पता होगा, you might have not observed or seen that particular thing with the reference to this. But now as you know, you can always go and see those things to understand these concepts much more better. So even आपने पूजा में banana leaf पे खाया होगा. In South Indian restaurants you might get to see these banana leaves plates. So all those things, small things, might help you to remember concepts and visualize them in much more easier way, and I would like to share some more examples like these as we go through these videos to understand the chapters. So do stay connected with Biophilia to see some these live examples that you can try on your own at your home and try to relate to your studies to it. So with this we see the two venations about reticulate venation and parallel venation. Now we can see the different types of leaves. So leaves अगर आपने notice किया होगा, once you go on morning walk, बहुत सारे plants होंगे, and you might also observe that all leaves are not same. So if you might have not observed it, next day you can always go and see out that how many different types of leaves actually the nature has. नेचर में बहुत सारे लीव्स है, and these leaves can be classified as simple leaves और compound leaves. Simple leaves है यानी एक सिंगल पत्ता डायरेक्टली ग्रो हो रहा है, that is a simple leaf. But compound leaves, that means small leaves are collectively coming together and forming a leaf, that is a compound leaf, which can be further divided into as pinnately compound or palmately compound, and there are many more further divisions as well. So ये तो बस एक flow chart था, एक idea था to collectively understand about types of leaves. Now we will go in the details of each of these one by one. So let's get ahead by understanding the simple leaves. Simple leaf जो होता है, it is the leaf that you can see many a times, जो आपने देखे भी होंगे, you might have seen them, but now here we see that the simple leaf is going to be that the leaf is not going to be divided, or the leaf blade is not going to be divided, and even if they try to be showing some lobes like structure, या उनमें अगर कोई ऐसे कर्व्स आ भी रहे होंगे, but these are, or these curves or these incisions are not going to touch the midrib, यानी वो completely leaf को दो टुकड़ों में नहीं बांट पाएंगे. These are not going to touch the midrib. They will just form some curve and go ahead and form the next lobe. So that particular thing is nothing but going to be called as a simple leaf until and unless they do not touch the midrib. अगर वो midrib को touch करते हैं, if they try to cut the midrib, then you can call it as a compound leaf. So now you can go out in the nature and try to hunt some of the leaves which are going to have these type of lobes, और आपको ऐसे incisions नजर आएंगे, but still these do not touch the midrib, and they are as a whole and called as simple leaves. So जब आप खुद जाके उन्हें ढूंढोगे and you will try to understand them, you will try to touch them and feel them, that will give you much more understanding, and that will also make your study much more interesting. So free time में जब बोर हो रहा हो, you can always go and find these type of different examples that you can understand and remember things much more better in a visual way. So simple leaf may you can have these particular leaves that I have tried to collect some and show you. So जैसे यहाँ पे एक leaf है which is going to be lobed, but still it is not touching the midrib. The lobes are not touching the midribs. That means it is still a simple leaf. So it is also going to have a bud at the axil of the petiole, and that is a type which can be seen in the simple leaves. Now we study about the compound leaf, wherein the leaf or the lamella is being completely broken. जो simple leaf होगा उसमें अगर incisions होंगे भी, even if it tries to come together at a converging point and then it again grows back, it is not going to touch the midrib. But now in the case of compound leaf, it is going to completely broke into different distinct leaflets. So छोटे छोटे leaves form हो जाएंगे and these are nothing but called as leaflets. So the leaf is going to have incisions which are going to reach the midrib. So if they reach the midrib, it is called as a compound leaf. If they don't, then these are called as simple leaves. So once they are reaching the midrib, now the leaves which are going to be formed are called as leaflets, क्योंकि अब ये छोटे छोटे हिस्सों में बट चुका है. And now here, if you can see in the particular photograph over here, then you can see that this particular is going to be nothing but the midrib. Ab midrib में से there are going to be small leaflets that are going to grow. So that is nothing but an example, or you can say a simple diagram to understand compound leaf. So ये example किसका है? ये example है of the compound leaf. But now if you want to show a diagram of a simple leaf, how would you show? You would show it like this. So like this is going to be the example of a simple leaf. So ये एक leaf है. These are a complete leaf but with these leaflets. So ये छोटे छोटे हिस्से क्या है? These are leaflets, but this is going to be an entire simple leaf. So leaf is going to be a larger one wherein the incisions do not reach the midrib, but the compound leaf is going to have the incisions reaching the midrib and completely broken into distinct leaflets. So ये difference पता करना बहुत important है, so that you do not get confused between a simple leaf and a leaflet. So now these compound leaves are not going to have any sort of bud at the axil of the leaflets. So axil of the leaflets where there are absence of buds, whereas at the axil of the petiole there is going to be a leaflet. So if you can see up here in this particular photograph, ये अभी for example this is going to be your branch, or this is going to be your stem. So this is your stem for example. यहाँ से there is going to be this area that is called as petiole. So what is this? This is going to be your petiole, and from here these are going to be small leaflets that are going to be seen. अब ये जो leaflets है, these leaflets are not going to have any sort of a bud at their axil area. Axil area तो ये हो गया, this is nothing but your axil area. Axil area में यहाँ पे bud नहीं होगा for the case of axil of the leaflets, but you can see some small areas, or you can see some small buds at the case of axils of petiole. So petiole के axil पे buds हो सकते हैं, but axil of the leaflets is not going to have any bud. So with that little thing you can understand कि वो axil किसका है? Is it of a petiole or is it of a leaflet? So that can also be helpful to understand or to differentiate between a simple leaf and a leaflet. So with this, I hope the introduction to the compound leaf is very much clear to you. सो एक आध दो स्लाइड्स पहले जो हमने एक फ्लो चार्ट देखा था वेर इन वी हैड सीन अबाउट द कंपाउंड लीव्स. सो कंपाउंड लीव्स में हमने देखा था अबाउट पिन्नेटली कंपाउंड एंड पामेटली कंपाउंड. So pinnately compound leaves में there are going to be midrib which is forming a common axis that is called as branches. So अब branches formation एक division से हो रहा है या if it is dividing twice or it is dividing thrice. So depending upon it there are going to be different types of sub classification जिसमें होता है unipinnate यानी अगर वो एक टाइम डिवाइड करे, bipinnate if it is dividing twice, tripinnate for thrice, and then finally the decompounded. So the first one we see is unipinnate. So unipinnate में भी दो classifications होते हैं, that is peripinnate and imperipinnate. So peripinnate में when the terminal leaflet is absent, you call it as a peripinnate compound leaf. Absent terminal है, that means these are going to have even number of leaves in the compound leaf. So leaflets even number के होंगे. So for example, if you want to understand it much more better, then see the first particular leaf photograph. So ये इसमें जो compound leaf है in which the central axis is going to be called as range, and this range which is common to all these leaflets is going to have the leaflets where the terminal leaflet is absent. Terminal absent है उसकी वजह से दोनों साइड पे एक एक leaflet होगा, making it to give you even number of leaflets. So कैसे होगा वो? First of all, if you want to draw a diagram, so this will be your common range, and over here one leaflet here, second, third, fourth, fifth, sixth, seventh and eighth. जो बीच में सेंटर में जो होगा the terminal leaflet will be absent, that gives you even number of leaflets. Now if you speak about imperipinnate, जहाँ पे terminal leaflet जो होगा it is present, giving you odd number of leaves found in the case of rose or neem. So नीम के पत्ते अगर आपने देखे होंगे, there is going to be this particular terminal leaflet which is going to create a odd number of leaflets on the common branch. So common branch, if you now want to show this, you will show this as a common branch, or common branch पे there will be first, second, third, fourth, fifth, sixth and one over here at the top. That gives you 7. That is an odd number of leaflets. So that was about peripinnate and imperipinnate compound leaves. Now about bipinnate leaves, जहाँ पे जो mid rib होगी, now it will divide second time and it will form a secondary axis or a branch wherein the leaflets will be present. So ये कैसे था? Unipinnate में जो था, suppose this was your stem. This was your stem, so orange is your stem, or you can say it was the branch, और इसके ऊपर the leaf did not directly come, वहाँ पे एक branch form हुआ, और ये जो branches था वो branches के ऊपर there was leaflet formation, right? So this was for the case of unipinnate compound leaf. But for bipinnate, what will happen? For bipinnate, this will be your stem. Okay, orange one is your stem, and then from that stem you are going to have a primary branch. Primary branch के ऊपर you will have this branch, and on this branch you are going to have the leaflets. So now you see that these are going to have two dark green lines, जबकि unipinnate में there was only one dark green line, but here you have two of them, that is bipinnate. So the examples of this can be acacia and mimosa. So mimosa जो है, you might have heard about touch me not plant. So touch me not plant जो होता है, this is this particular plant, that is touch me not plant. So you might have seen कि आप उसको touch करते हो and you know the leaves shrink. So that is nothing but a mimosa plant which is having leaves of bipinnate compound leaf. Tripinnate compound leaf जो होगा, it is going to have the division of secondary axis as well to form the tertiary axis, and the tertiary axis is going to have the leaflets. So that case can be seen in the case of drumstick and Melia. So suppose for example, again this is your stem, The orange one is your stem. The first, that is the primary division. This is your secondary division, or tertiary division pe you are going to have your leaflets. So this way you can understand that how the tripinnate leaves are going to be seen. So you can see over here as well. So यहाँ पे नीचे हो सकती है, there might be a branch or the stem, and then this becomes your first little thing, the first primary one. This becomes your secondary, and then the tertiary. So that becomes a tripinnate. अब पढ़ते हैं about decompound. Decompound में the branches is going to divide repeatedly, repeated division होगा, and there will be no such definite pattern wherein these are going to get divided. So बहुत सी बार होता है कि वो इतना ज़्यादा repeated division है कि these are going to have narrow segments. So that is nothing but giving you the decompounded effect. So over here these type of leaves can be seen for the case of carrot leaves, for coriander यानी धनिया. धनिया के पत्ते you might have seen every time in your kitchen. So धनिया के पत्तों को you can go and observe. You can see that the compounded leaf can be seen. So carrot के जो leaves होंगे, coriander leaves as well as for parthenium leaves, you are going to have this type of compound leaf. Now about palmately compound leaf. Palmately compound leaf में the leaflets are going to remain attached at a common point. यानी अगर आप pinnately compound के बारे में बात कर रहे हो, so pinnately compound leaf is going to have the presence of branches. Okay, so on the branches the leaflets were present, but if you speak about palmately compound, then they will have a common point, and that common point is nothing but tip of the petiole. So in this also you are going to have divisions, that is unifoliate, bifoliate, trifoliate, quadrifoliate, and multifoliate. So now it here depends upon how many leaves are going to be attached onto the common point. So if you have unifoliate, that means only one leaf is going to be present, only one attachment is there. So you can see how the leaf is going to be. Leaf होगा यहाँ पे एक ऐसा bulge हो जाएगा, यहाँ पे cut होगा, and then a bigger leaf is going to be present. So that gives you the idea about the unifoliate leaf. So this can be seen for the case of citrus fruits like oranges and lemons will have this type of leaves. If you ask for bifoliate, you can see it in the case of begonia. So here you can see यहाँ पे कैसी condition है. You are going to have this branch, this coming over here, this is your common point, and then from here the leaves are going to be seen. So you can see how the condition is. So one coming from this side, one coming from this side, और यहाँ से दोनों ने Y बना के common point पे attach हो गए. Then for the trifoliate, you can see one is going to come from here, one leaf attaching here, one coming from here, and the third one from here at this particular common point. So this type of leaves can be seen in the case of trifolium, dolichos, and even bean leaves. So trifolium जो होता है, trifolium is also called as white clover. So white clover in foreign countries or even in India, you can find this particular grass, and it is said lucky to have to find four-leaved clover. So four-leaved clover अगर आपको attached मिल जाए, so it is considered that you are lucky to see that four-leaved clover. क्योंकि बहुत rarely you are going to find the leaves that is going to be four leaves are attached at a single point. So that kind of four-leafed clover दिख जाए तो बोलते हैं lucky है, and that four-leafed clover is nothing but going to be our next type, that is quadrifoliate. Quadrifoliate may, like the case of Marsalia, there are going to be four leaflets attached at one single common point. So this is going to be the common point, or you can say the tip of the petiole. So petiole क्या होता है? Petiole is nothing but going to be the stalk of the leaves. So multifoliate में there are going to be more than four leaflets going to stick at one particular point, and at this particular point you can say that these type of leaves can be seen in the case of bombax tree, that is cotton silk cotton tree. So likewise you can understand the difference between pinnately compound leaves or palmately compound leaf. दोनों भी compound है, that means there is going to be division of the midrib, but how these are going to be arranged is going to differentiate them into pinnate and palmately compound. So now here we are going to understand about one more interesting thing, that is called as phyllotaxy. Phyllotaxy is nothing but the study of pattern of leaves, how they are going to be arranged on the stem or its branches. So जो arrangement होगा वो हर time अलग अलग होगा. So there are going to be three major arrangements. The first one being the alternate phyllotaxy, second as opposite phyllotaxy, and the third as world phyllotaxy. So alternate phyllotaxy जहाँ पे a single leaf is going to be present at each node. एक node है, एक leaf है, that means it is a alternate phyllotaxy. So you can remember alternate phyllotaxy as what? You can remember it as one leaf per one node. Okay, one leaf per one node, that is alternate phyllotaxy, which you can see in the case of China rose यानी hibiscus में दिखेगा, in the mustard and even in sunflower. So you know, knowingly or unknowingly sunflower की drawing आपने बचपन में बनाई होगी, and sunflower की drawing जब आपने बनाई होगी, you might have always shown the leaves in that particular fashion, that is alternate phyllotaxy. You might have unknowingly showed it. आपने एक पत्ता यहाँ पे बनाया होगा, एक पत्ता थोड़ा ऊपर बनाया होगा. That is nothing but showing the alternate phyllotaxy. Opposite phyllotaxy जो होता है, there is going to be a pair of leaves arising at each node. इसका मतलब क्या होता है? There are going to be two leaves per node. That gives you the idea of opposite phyllotaxy, जो guava और calotropis के plants में मिल सकता है. So you can have the visual appearance of the leaves, यानी एक यहाँ पे है और एक यहाँ पे है. So this is the common point, that is having opposite phyllotaxy. Third है world phyllotaxy, wherein you are going to have more than two leaves at each node, यानी 2 plus leaves per node is going to give you the world phyllotaxy. That can be seen in the case of Allistonia and Nerium. So you can see how the particular world phyllotaxy is going to be visualized. So that is about the arrangement, how the leaves are going to be found. Either वो एक leaf एक node पे है, या two leaves on one node, or more than two leaves on a single node. So on that basis you classify or you call that study as phyllotaxy. Next is modifications of leaves. So modifications में the first modification that comes to your study is going to be leaf tendrils. Leaf tendrils जैसे हमने stem tendrils पढ़े थे in the previous class. Similarly, you are going to have leaf tendrils. So if you don't remember about the modifications of stem, so for the modifications of stem, you can refer to the link given in the description box, and you can go and revise those particular topics as well. So about leaf tendrils over here, these are going to be the leaves which are going to modify themselves into long, slender and thread-like sensitive structures. Sensitive structures because even these are going to help to coil around and give support to the plant while climbing. जैसे stem tendrils sensitive थे, so that they can help in climbing up the particular pole या support पे they could climb up. Similarly, even leaf tendrils have the same function. So जो stem tendrils थे वो gourds में थे, जैसे like you had stem tendrils in the case of watermelon, you had them in the case of cucumber, you had them in grapes. So likewise in stem tendrils, now the leaf tendrils are going to be found in peas and in sweet pea. So peas or sweet pea में leaf tendrils है. If in the case of grapes or watermelon or cucumber, if you are asked, then these will have stem tendrils. So to remember, both are going to be tendrils, but leaf है या stem है, you have to remember it on the basis of examples. Next is going to be about leaf spines. So leaf spines को अगर if you want to coordinate with your revision, so you can remember them with the help of thorns. So जैसे stem का modification था thorns, वैसे leaf का modification होगा leaf spines. So leaf spines can be seen, or these are modified into small sharp pointed structures which are going to reduce their transpiration and for protection of the plants from the browsing animals. जैसे thorns भी protection के लिए useful थे, similarly the leaf spines are going to be used for protection for the plant, as well as these have additional function, that is to reduce the loss from the transpiration. So these are generally found in the plants which grow in arid regions. एरिड रीजन्स में जहाँ पे बहुत ज़्यादा गर्मी है, वाटर सोर्स की कमी है, वैसी जगहों पे these plants are going to convert their stems into phylloclads. So you might have remembered about the stem modification. So stem is going to modify into phylloclads. So phylloclad में जब modify हो जाता है, they become cylindrical fleshy stems. So in the case of cactus, so similarly, the leaf is going to get modified into leaf spines in the case of aloe vera and cactus. So similarly, as we have completed over here about revision of the previous modifications, as well as हमने leaf modifications को भी पढ़ा है. In similar ways, you can also go and try to build some particular relationships with your previous topics so that you can revise those and learn these new things again. So modifications of leaf, the third is going to be storage organ. Storage organ में यानी there are going to be fleshy leaves which are going to store food, and that can be seen in the case of onion and garlic. So just for revision's sake, can you remember that what sort of root did onion or garlic have? So not root, what kind of stem did onion or garlic have? So they had the reduced stems, they had reduced disc like stem. So onion or garlic के पास क्या होता है? These are going to have reduced and disc shaped stems. So likewise, जैसे आपको examples आते हैं, similarly you can always go and revise those previous topics that you have learned. So onion or garlic में reduced disc like stem है, but the leaves are going to convert or modify into fleshy leaves to store food. Then the fourth modification is going to be about phyllodes. जैसे हमने stem modifications में पढ़ा था about phylloclad. So not to get confused between phylloclad is going to be a stem modification, phyllodes is going to be a leaf modification. So it is important to remember the difference between the two. Phyloclad क्या था? Phyloclad was nothing but when the stem is going to convert into cylindrical fleshy substance which can photosynthesize is going to be a phyllodes. But phyllo क्या होता है? It is going to be where the leaves are going to become small and short lived, and the petioles are going to modify into forming flat green colored leaf like structure which performs photosynthesis is called as phyllodes. So phyllodes किस में मिलेंगे? Phyllodes can be seen in the case of Australian acacia. So here you can see that this particular green structure is going to be the petiole. So petiole, the stalk of the leaf tha, it is going to become flat and green, whereas the leaves, so these are the normal leaves, these are becoming small and short, and after some time these are going to fall off. So these will not survive for a longer period of time, and this can be seen in the case of Australian acacia. Then for the leaf pitchers may these are going to be the leaves which are going to modify themselves in a very beautiful manner. और ये अपने आप को ऐसे मॉडिफाई करेंगे कि दे बिकम द insectivorous plants. Insectivorous plants because these are going to consume insects. These are going to get their nitrogen sources. What are they going to use them for? These are going to use for nitrogen sources because ये insectivorous plants ऐसे जगहों पे उगते हैं where there is deficiency of nitrogen compounds in the soil. So nitrogen compounds soil से नहीं मिलने पे these plants are going to get their nitrogen from the catched or trapped insects. So for that reason the leaves are going to modify into pitchers. So एक ऐसे vessel type they will convert, and that can be seen in the case of pitcher plant and Venus flytrap. So here you can see how the particular leaf is going to convert itself. So आपको नजर भी नहीं आएगा कि it is a modification of leaf. You might think it is a different part of a plant, but now as you have heard and learnt about it, you know that these are nothing but leaf modifications. So ये जो होगा, this is going to be the leaf modification from wherein the insect is going to get trapped, and then this particular shut is going to close, and then the leaf is going the pitcher is going to get closed and the insect is trapped. So likewise these are some of the modifications of leaf. So 5 modifications of leaf we have covered. So likewise I hope you understood all of them. So after all, when we have completed to understand about the theory of morphology of leaves, so it's time now to understand how much you have learned. So ये कुछ questions है that you can solve to recall about the things that we have learned in this video. So these are not sufficient for your exams or to go for a thorough understanding, but I hope that this might help you to run your horses of your mind so that you can actively recall about what you have learned. So आप उसको answers comment section में you can share those answers, as well as when you are going to solve new questions. हो सकता है कि कुछ questions आपको बहुत अच्छे लगे, you might feel that these questions needs to be shared, then you can always go and write it down in the comments section so that everyone who visits our channel will be benefited and might thank you for helping out with those questions. So let's make a healthy community, a healthy competition on this channel with the help of these comment section. So with this we complete half of the chapter with the part 3 of morphology of leaves. हमने morphology of roots भी cover किया है. We have covered the morphology of stem, and now with leaves we come to the half mark of the chapter. All the links will be provided down in the description box. You can go and revise those things as well. Till the time we come back soon with the next video, do let us know how do you like these videos, and don't forget to like, share and subscribe to our amazing channel. Till the time we meet back again, keep studying, keep smiling. Bye bye everyone. Thank you.